Welcome back to Infinity Beyond, where we explore not just space, but time, destiny, and the ultimate fate of everything. In our last segment, we stood on the edge of forever, contemplating the heat death of the universe, a future of cold darkness and silent stillness. But even in that distant age, one type of object will remain: black holes. Massive, mysterious, relentless. They are the ultimate cosmic scavengers, consuming light, matter, even time itself. And long after the last stars flicker out, black holes will endure as the final giants of a dying universe. Let's begin with the basics. A black hole forms when a massive star collapses under its own gravity at the end of its life cycle. The collapse becomes unstoppable, compressing matter into a singularity, a point of infinite density. Around this singularity is the event horizon, the boundary beyond which nothing can escape, not even light. Once thought to be merely theoretical, black holes are now a confirmed reality. We've seen the gravitational dance of stars orbiting invisible giants. We've detected gravitational waves from their collisions. And in 2019, we saw the unseeable. The first direct image of a black hole's shadow in the galaxy M87, an orange halo of superheated gas spiraling into darkness. Black holes come in various sizes. Stellar black holes weigh a few to dozens of solar masses. Intermediate black holes, still mysterious, range from hundreds to thousands of solar masses. Supermassive black holes, millions to billions of times the mass of the Sun, anchor the hearts of galaxies. And then there are the truly speculative ones, primordial black holes, which might have formed during the chaotic infancy of the universe itself. As time marches on, black holes will dominate the cosmos. In a future where stars no longer shine and galaxies drift apart into isolation, black holes will be the only massive structures remaining. Like sentinels of entropy, they will consume what's left: wandering stars, neutron remnants, and even other black holes. Black holes don't just swallow, they also reshape space-time. Their gravity bends light, distorts time, and opens windows into the nature of reality. Near a black hole, time slows dramatically. A second for someone falling in might be years for an observer far away. This gravitational time dilation means that black holes are not just physical objects. They are clocks, gateways, and possibly bridges to something deeper. Some theories even suggest that black holes could harbor wormholes, shortcuts through space-time. Others propose that information entering a black hole isn't lost, but encoded on its surface, a concept known as the holographic principle. This remains one of the greatest unsolved problems in physics. What happens to information inside a black hole? And here's a staggering truth: black holes aren't forever. In 1974, Stephen Hawking revolutionized our understanding by showing that black holes emit tiny amounts of radiation due to quantum effects near the event horizon. This Hawking radiation causes black holes to lose mass over time, very, very slowly. For a stellar black hole, it would take more than a trillion years to fully evaporate. But eventually, in the distant black hole era, they will fade into nothing, leaving behind only fading ripples in space-time. Picture it: the last light in the universe is not a star, but the faint whisper of Hawking radiation from a solitary black hole slowly evaporating into the void. A final sigh before silence. But let's not just talk about endings. Black holes are also beginnings. They fuel the birth of galaxies. They shape cosmic structures. The violence of their mergers generates gravitational waves that ripple through the cosmos. Their existence pushes the boundaries of our understanding, blending quantum mechanics, thermodynamics, and general relativity. Could advanced civilizations use black holes? Some thinkers propose using the intense energy of matter spiraling into a black hole as a power source, perhaps through a Dyson sphere-like structure called a Chkotov thruster to move entire star systems. Others imagine black holes as cosmic data vaults, time capsules for the far future, or even as portals, if we ever unlock the true nature of space and time. The truth is, we're only beginning to understand these titanic objects, and yet they are already key players in the universe's story, from its energetic youth to its frozen epilogue. Let's pause for a moment. Imagine standing at the edge of a black hole's event horizon. You look out and see the universe speeding up, racing forward in time, galaxies evaporating into darkness. Behind you lies the unknown. Ahead of you, everything is vanishing. You are at the boundary between what is known and what is unknowable. And in that moment, you realize, this isn't just science. It's poetry. It's destiny. It's awe. In our next segment, we'll turn from the end to the hypothetical, exploring bizarre ideas about what could come after heat death, rebirths, rebounds, quantum cycles. Could the universe begin again? Until then, remember, black holes are not monsters. They are memory. They are math. They are mystery. And for now, they are forever.